Hello there! I want to replace this standard glass lab thermometer by this. A DS18B20 temperature sensor on a stick. Of course, it has no scale, but instead you can connect down the line a microcontroller or something to display or read the temperature. I made a video about that. Card link. Anyway, there is one problem. I need my DS18B20 to be able to withstand solutions of caustic soda used for developing photosensitive PCB material and sodium persulfate solutions, which are, also not so good and used for etching PCBs. Something a run-of-the-mill glass thermometer has absolutely no problems with. And that's where these glass tubes come in. Yeah, they were on the mailbag card link. They're just big enough so you can shove a DS18B20 down. Okay, so we're almost finished. We just have to seal off the end of the tube and isolate the wires, of course, and attach a cable, and we're done. And that should be quite simple. I remember senior high chemistry. We took such glass tubes and we heated them up here over a Bunsen burner, and then we pulled and it separated somehow. I think I remember. It's been a while. Let's see how that works out. But there's one question. Why go through all the trouble with the glass tubes when you could use simply, let's say, a polyethylene tube, which is also quite resistant against chemicals? The answer is easy. Glass conducts heat several times better than any plastic. And that's kind of important for a thermometer. So, without further ado, let's start with the hot work. Okay, let's do this. Air shut off, gas, and stop! Never have a blowtorch with a gas bottle unsecured somewhere when you're not actually holding it in the hand and doing stuff, which are these intended for. You have to secure it because you don't want that to be knocked over and roll on the floor, burning. So do yourself a favor. Use some jig to secure the bottle so it cannot roll away on the floor and burn your house down. Okay? So let's try that. And I might be a little bit mute because, That looks promising. Oh. So, that was it. Let me make a blow test. I'm actually blowing. But, that was almost too simple, was it? I'm flabbergasted. Anyway, it might be a little bit hot, so let's wait a little bit until this cools down. Now another thing is, yeah, the edge here is a little bit rough, and I just melted a wee bit here, okay? Give me a sec, I zoom you in this time. Now the problem here is I melted it and it got a little bit smaller. So yeah, I have to work the glass a little bit. Now that didn't work at all, did it? Okay, let's try another time. Okay, this is also good, I guess. I have to, hot, sorry, to let it cool down. Yeah, but this time, yeah, worked perfectly, and I didn't overheat the other end with the sharp edge. I just wanted to little bit to melt it so that's no longer sharp. That's all. And yeah, the length is now also 20 centimeters aboutish, not too short. And I was wearing protective glasses above my normal glasses, okay? Safety first. Slight change of plans. I initially attached that sensor here to these stiff wires so I can shove it down the tube real easy. Yeah, I intended to put a blob of some silicon thermal adhesive at the bottom so that the sensor is even better thermally connected to the glass than with just a little bit of air around it. And yeah, shoving down the silicone goo, I have a fitting wooden stick here, and that works too. But in fact the sensor goes down so easy. I attached it now, a second one, directly to the cable. So yeah, some silicone goo here, shove it down, some silicone goo here at the top, to seal in the cable, and poof. Only problem is I ran out of silicone thermal adhesive. I used it all up for the hot and wet parts. And instead of waiting now a week until a new supply arrives, I think, I'll end the video here and I will show you the sensor in its finished form at some other time. Okay, bye.